12,800 years ago, something happened to the Earth that scientists still cannot fully agree on. The planet had been warming for thousands of years, climbing steadily out of the last ice age. Glaciers were retreating, forests were spreading north. And then, in what geological terms call almost an instant, the warming stopped. Temperatures crashed. In some places, the cooling happened within decades, maybe less. Ice crept back over land that had just started to green. A period that should have been the slow, comfortable start of our modern world instead turned backward into a deep freeze that lasted more than 1,000 years. Scientists named this cold snap the Younger Dryas, after a small Arctic wildflower whose pollen shows up in the sediment right when the cooling begins. And if you go looking for the exact moment it happened, you can actually find it. Not in a history book, in the ground itself. At dozens of sites across North America, and later in Europe and beyond, geologists kept running into the same strange feature. A thin, dark band of soil, sometimes barely the width of a finger, sitting right at that boundary. Underneath it, the world looks like the end of the Ice Age. Mammoth bones, Clovis spear points, the same fluted stone tools that once defined the whole story of the first Americans. Above it, both are gone. The big animals vanish from the record. The Clovis toolmaking tradition disappears. Something ends right there in that dark little seam, and for decades nobody could agree on what. They started calling it the black mat. And in 2007, a team of researchers proposed an answer so dramatic it would dominate headlines for the next 2 decades. They argued the black mat was not just a coincidence of timing. They said it was a crime scene. Their theory was that a comet, or a swarm of comet fragments, exploded in the atmosphere above North America roughly 12,800 years ago. Not a crater-forming impact, but something closer to the Tunguska event in Siberia in 1908, where an exploding space rock flattened 800 square miles of forest without ever touching the ground. Multiply that by dozens, scatter the fragments across an entire continent, and you get, they argued, exactly the kind of catastrophe that could kill off the mammoths, wipe out the Clovis hunters' way of life, and choke the sky with enough soot and dust to throw the whole planet back into an ice age. It was an enormous claim. And enormous claims need enormous evidence, so the researchers went looking for it, and they said they found it everywhere. They pointed to tiny glass beads called microspherules, droplets of rock melted so violently and cooled so fast that they froze into perfect little spheres, the kind of thing you see raining, down after a high-energy impact. They pointed to nanodiamonds, microscopic diamonds that form under pressures and temperatures you do not get from a campfire or a forest fire, but that you do get from a shock wave tearing through the atmosphere. They pointed to a spike in platinum, an element that is vanishingly rare in the Earth's crust but common in asteroids and comets, and they found that spike sitting at the exact same layer as the black mat, at site after site, on more than one continent. And they pointed to something with a very specific, very technical name, shocked quartz, grains of ordinary sand-forming mineral that had been deformed by pressures so extreme that microscopic fracture lines form inside the crystal itself, fracture lines, that, as far as anyone knew, only formed during a genuine cosmic impact or a nuclear detonation. Put those 4 things together, the researchers said, at more than 50 sites across 2 continents, all lined up at the same moment in time, and you are not looking at coincidence. You are looking at the fingerprint of a disaster. The list of sites kept growing too, which is exactly what made the theory so hard to dismiss out of hand. Researchers reported the same combination of markers, not just in North America, but at a site in Syria linked to some of the earliest known farming settlements in the world, and later in lake beds and coastal sediments scattered across Europe. If it really was a coincidence, it was an oddly consistent one, showing up on more than one continent at very close to the same moment in deep time. For a while, it was one of the most talked about ideas in earth science. It offered a tidy, thrilling explanation for 3 mysteries at once. And why did the Ice Age suddenly reverse itself? Why did the mammoths and giant sloths and saber-toothed cats disappear so abruptly? And why did the Clovis people, the same first Americans we talked about before, vanish from the archaeological record almost overnight? One comet, one afternoon, geologically speaking, 3 mysteries solved in a single catastrophic stroke. It had the same seductive elegance that made the old Clovis first migration story so appealing for half a century. A single dramatic cause, a clean date, a story you could tell in one sentence at a dinner party. And just like Clovis first, elegance should have been the first warning sign, not the last. Because almost immediately, other scientists went looking at the same layer and started finding reasons to doubt it. The first and most basic problem was the simplest one in the world. If a comet or swarm of comet fragments really did explode over North America with enough force to trigger a global climate shift, where is the crater? Impacts of that scale should leave scars in the landscape, and after years of searching, nobody could point to one. Airburst defenders had an answer for that. Tunguska did not leave a crater either, they said, because the object exploded in the air rather than slamming into the ground. That is true, and it is a fair point. But critics pushed back harder. An airburst powerful enough to be felt across a continent and disrupt the global climate would need to be almost unimaginably large. And an object that large exploding in the atmosphere should still leave unmistakable traces in the geological record beyond. A scatter of microscopic particles. The math, several independent teams argued, simply did not add up. You could not get a Tunguska-sized blast to explain a hemisphere-wide climate event without invoking something so much bigger that it stopped looking like Tunguska at all. Then came the harder problem, the one that echoes almost exactly what we talked about with stone tools and geofacts. Shocked quartz is supposed to be one of the most reliable fingerprints of a genuine impact, because almost nothing else on Earth produces those specific fracture patterns inside the crystal. Almost nothing else. But when independent researchers examined the quartz grains presented as evidence for the Younger Dryas impact, using the same rigorous criteria that planetary geologists use to confirm shocked quartz at confirmed impact sites, like the crater linked to the extinction of the dinosaurs, many of them concluded the grains did not meet the standard. The fracture patterns were real, but similar patterns, they argued, can form from ordinary tectonic stress, volcanic activity, or even the pressure of glacial ice grinding over bedrock for thousands of years. It was the geofact problem all over again, just wearing a different disguise. Nature is extremely good at mimicking the signatures we use to prove catastrophe, and separating a genuine shockwave from an ordinary geological accident turns out to be brutally difficult when you're working with particles smaller than a grain of sand. The microspherules ran into a similar wall. Critics pointed out that tiny melted rock droplets can form in volcanic eruptions, in ordinary wildfires, burning hot enough to melt certain minerals, and even from industrial pollution. In more recent layers, fly ash and foundry slag drifting down from factories and getting mixed into the sediment record by accident. Some of the sites where researchers reported these spherules, critics noted, had also been disturbed by centuries of farming, construction, and human habitation, which made it much harder to be certain that what was being measured actually belonged to that one thin moment in time, 12,800 years ago, rather than material that had been shuffled in from somewhere else, sometime else. And then there was the platinum. This is where the story gets genuinely interesting because, unlike the quartz and the spherules, the platinum anomaly turned out to be real, and it turned out to be reproducible. Independent labs, working on independent samples in Greenland ice cores and lake sediments, across North America, in a site in Patagonia, at the southern tip of South America, kept finding the same thing, an actual spike in platinum concentration sitting right at the Younger Dryas boundary. That is not nothing. Platinum does not typically get concentrated at the Earth's surface the way it can be inside an asteroid or a comet, so a genuine, well-documented spike is a real puzzle that deserves a real explanation. But a real anomaly is not automatically proof of the exact explanation someone proposes for it. Volcanic eruptions can also raise platinum group element concentrations. Certain wildfire conditions can as well, by concentrating trace elements already present in soil and vegetation as they burn. The presence of a platinum spike told scientists that something unusual happened at that boundary. It did not, on its own, tell them what. So for years, the Younger Dryas impact hypothesis sat in the same kind of limbo we described, with the rock shelter in coal country, too much evidence to dismiss outright, too many holes to fully accept. Comprehensive reviews of the accumulated data, published through the early 2020s, kept landing on roughly the same verdict. No confirmed crater, no dating scenario that all the sites agreed on cleanly. Markers that looked compelling in isolation, but grew shakier the closer you examined them under the same strict standards used everywhere else in impact science. One widely cited assessment concluded flatly that the hypothesis had never converged into a single, internally consistent, reproducible story more than 15 years after it was first proposed. That is an unusually long time for a scientific claim to remain this unsettled, and it is exactly the kind of long, grinding limbo that tends to end one of two ways. Either new, cleaner evidence finally tips the balance toward acceptance, the way it eventually did for the rock shelter and the cave full of ancient human waste we talked about, or the accumulated weight of failed replication and methodological problems finally tips it the other way. And very recently, in the last couple of years, we have gotten a much clearer answer to which direction this one is going. In 2025, researchers connected to the same group that has driven much of the impact hypothesis published new work claiming fresh support, including a study of shocked quartz grains from a site on an island off the California coast, arguing the grains matched patterns seen at more than 24 other locations already accepted as evidence for cosmic impacts elsewhere in the geological record. Around the same time, a separate team published an analysis of a Greenland ice sheet sequence, reporting platinum, shocked quartz, and nanodiamonds all clustered together right at the Younger Dryas boundary, and using computer modeling to argue the combination was consistent with a cosmic airburst rather than any ordinary earthly process. On the surface, it looked like the hypothesis might finally be climbing out of limbo and into acceptance. But then, the same layer got a second look, and this time it did not survive the scrutiny nearly as well. In early 2026, the scientific journal that had published two of the group's most recent papers, one examining marine sediment cores from the waters between Greenland and Canada, the other presenting new shocked quartz evidence, retracted both of them. The reasons were not small technical quibbles. Independent experts who re-examined the microscope images used to identify supposed comet dust in the ocean cores determined that a significant portion of what had been labeled extraterrestrial material was, in fact, an ordinary and extremely common type of marine plankton, misidentified. The radiocarbon, dating methods used to place the samples inside the Younger Dryas window were found to be inappropriately calibrated for the location and time period involved, meaning some of the ages presented as falling neatly within the impact window may not have belonged there at all. Reviewers also flagged citations in the papers that did not actually support the claims they were attached to, along with signs suggesting undisclosed use of artificial intelligence tools in preparing the references, and a sampling approach that made it impossible to tell whether the reported spike was a genuine one-time event or just ordinary background variation. This was not the first time work from the same research circle had come apart under close examination either. Just a year earlier, one of their most publicized papers, a claim that an ancient city in the Jordan Valley had been leveled by a comet airburst and that the destruction may have inspired the biblical story of Sodom, was retracted for strikingly similar reasons: mischaracterized data, findings that outside experts could not reproduce, and interpretations that seemed to have been built to fit a conclusion the researchers had already settled on before the evidence came in. It is worth saying plainly that the researchers behind the original hypothesis never went quiet in the face of the criticism. They kept publishing. They wrote books for a general audience, gave interviews, appeared on popular podcasts, and built a dedicated research organization whose stated purpose was to keep hunting for evidence of comet impacts in the deep past. There is nothing wrong with persistence in science, and plenty of correct ideas have survived exactly this kind of long, stubborn defense. The rock shelter in coal country survived because its excavator refused to let a fair objection go unanswered. The difference is that persistence only vindicates you if the evidence eventually holds up to hostile scrutiny. The excavator in Pennsylvania tested for coal contamination, and it was not there. The team behind the Younger Dryas comet kept adding new sites and new samples, and when outside experts finally sat down with the newest of those samples, several of the central claims did not survive contact with a second pair of eyes. Sit with that pattern for a second, because it is the mirror image of the pattern we saw with the first Americans. There, the establishment kept rejecting good evidence because accepting it meant admitting the textbook was wrong. Here, a group of researchers kept publishing dramatic, headline-grabbing claims, and time after time, when other scientists actually sat down and checked the underlying data, plankton turned out to be comet dust. Ordinary fracture patterns turned out to be labeled as impact, grade shock features, and a Bronze Age town fire turned into a biblical comet strike. That is not the immune system of science failing to update. That is the immune system doing exactly its job, catching claims before they hardened into the next generation's Clovis first. None of this means every scrap of evidence for something unusual happening at the Younger Dryas boundary has been explained away. The platinum spike is still there, still real, still reproduced independently by labs with no connection to the retracted papers, and it still does not have a fully settled explanation. Most climate scientists today favor a very different, much less cinematic story for what actually triggered the sudden cooling. A massive pulse of fresh meltwater pouring off the collapsing Laurentide Ice Sheet into the North Atlantic Ocean, diluting the salty water that drives a critical ocean current, the one that carries warmth up from the tropics toward the north. Shut that current down, even temporarily, and the whole hemisphere can plunge into cold within a matter of years, no comet required. Ice cores and ocean sediment cores both show signs of exactly this kind of freshwater pulse arriving in the North Atlantic, right around the same window of time, which is part of why most climatologists consider it the leading explanation rather than a fallback. That explanation fits the ocean and ice core records more comfortably than the impact story ever has, though even it does not perfectly explain every trace of platinum or every layer of soot found at these sites. The honest, unglamorous truth is that the Younger Dryas cooling event still has loose threads nobody has fully tied off. What has changed, and changed hard in just the last year or two, is confidence in the comet catastrophe version of the story. The single most dramatic explanation, the one with the Tunguska-sized fireballs and the vanished megafauna, and the extinguished Clovis hunters all falling in one afternoon, has now had 2 of its own recent flagship papers pulled from the scientific record for misidentifying basic evidence, on top of an earlier retraction for one of its most famous individual claims. When you re-examine the layer itself, the black mat that started this entire investigation, what you increasingly find underneath the excitement is not a comet. It is a cautionary tale about how easy it is to see a catastrophe in the data when you are already looking for one, and how much harder, slower, and less thrilling the real answer usually turns out to be. So maybe that is the actual ending here, the one that does not fit as neatly on a thumbnail. Something did happen 12,800 years ago. The cold snap was real, the platinum is real. The mammoths really did disappear, and the Clovis toolmakers really did vanish from the record within a strikingly narrow window of time. But the most sensational explanation for all of it, the one that made for the best headlines, is the one that keeps falling apart every time someone looks closely enough at what is actually sitting in that layer of dirt. And if there's a lesson buried in there alongside the platinum, it might be this one. The boldest theory is not always the true one, and sometimes the bravest thing a scientist can do is not defend a comet to the end. It is admit that the ground underneath the mystery does not say what you hoped it would say. And maybe that is worth remembering the next time a headline promises that scientists have finally solved an ancient mystery in one dramatic stroke. Real answers in earth science almost never arrive that cleanly. They arrive in pieces, get challenged, get retested, sometimes get retracted, and only settle into something close to certainty after years of exactly the kind of grinding, unglamorous scrutiny this layer has now been through twice. What do you think really happened at that boundary? A dying ice sheet flooding the ocean, or something we still have not fully ruled out? Leave your answer below. I read everyone.